All right, let's talk about that incredible return of NASA's Artemis 1 mission. I'm sure you saw it. The Orion capsule comes screaming back to Earth, and it looks like it literally bounces off the atmosphere. So what was that all about? Was it some kind of accidental ricochet, or was it something way, way more calculated? Today, we are going to unpack the mind-bending physics behind Orion's fiery ride home. You know, the image that probably pops into your head is a stone skipping across a lake, right? That powerful, kind of wild, uncontrolled bounce. It's a fantastic visual, for sure, but it's not quite what was happening with Orion. So let's just ask the question straight up, because this is what everybody was wondering. Did the Orion capsule, as it was hurtling back to Earth at thousands of miles per hour, actually bounce off our atmosphere? The short answer, well, not exactly. But honestly, the real answer is so much cooler. What we all saw wasn't an accident at all. It was this perfectly choreographed masterpiece of engineering. What we were actually witnessing was a very deliberate maneuver that NASA engineers call a skip entry. Yeah, a skip entry. This wasn't some kind of mistake or a lucky break. It was the plan from the very beginning, and it's a technique that's absolutely vital for bringing astronauts home safe and sound from the moon. And you know, the key word in all of this is control. A skip entry is totally pre-planned. The capsule dips into the atmosphere, uses its own aerodynamic lift to kind of pop back out for a bit, and then it comes back in for that final plunge to the ocean. Look, here's the crucial difference. A bounce would be totally uncontrolled, right? Unpredictable and incredibly dangerous. A skip, on the other hand, is a precision maneuver. It uses the laws of physics to its own advantage. It's really the difference between just skipping a rock across a pond and expertly piloting a glider. So, how exactly does this incredible atmospheric dance even work? Well, it's a pretty fascinating process, and we can break it down into 4 main phases. Okay, here's how it goes. First, Orion just plunges into the upper atmosphere. The drag acts like a giant set of air brakes, scrubbing off an insane amount of speed. Then, and this is the cool part, it uses its aerodynamic shape to generate lift, and it actually climbs back out of the thickest part of the atmosphere. And then finally, it dives back in for its final descent and splashdown. It's just a brilliant 2-step process to manage a mind-boggling amount of energy. Now you might be thinking, okay, why go through all this trouble? Why not just come straight in? Well, it turns out this maneuver has some huge advantages that are absolutely critical for missions coming all the way back from deep space. And you don't have to take my word for it. This quote from NASA really says it all. For the kinds of extreme speeds you see on a lunar return, we're talking almost 25,000 miles per hour, this technique isn't just a nice to have, it is a requirement to survive the unbelievable heat and forces of re-entry. And the benefits are just massive. By doing this skip, NASA can dramatically improve its landing accuracy, which gives them a much better shot at hitting their target in the ocean. It also offers incredible flexibility, opening up way more potential landing zones around the globe. And, like we just said, it's absolutely essential for surviving the trip home from the moon. So the next time you hear someone say that Orion bounced off the atmosphere, you'll know the real story. It wasn't some lucky skip. It was a calculated, controlled, and frankly, brilliant piece of orbital mechanics, all designed for one thing: getting our astronauts home safely. This technology is absolutely key for getting back from the moon, and that leaves us with a really fascinating question to think about. As we start setting our sights on Mars, where the atmosphere is totally different and the return speeds will be even faster, what new re-entry challenges are we going to have to solve next?